Welcome to the video for the fourth problem on the second exam. In this one, we need to find the shear stress at a particular point in a thin-walled shape. In question 4, we are given a thin-walled rectangular section and a point, and we are asked what the shear stress is at that point if it is subject to a shear of, in this version, 125 kips, and we are also given the second moment of inertia, which is going to be 85.3 inches to the fourth. With thin-walled shapes, it's important to know how the shear is flowing. So, what we'd obviously like to use is this equation. We want to use that the shear stress is equal to the moment of area times the applied shear divided by the second moment of inertia and the thickness. This is given, this is given, this is given, because we're also given that the thickness is equal to 0.4. So the only question is really, what is Q, the first moment area? So for that question, we do need to know, hey, focus. We do need to know how it flows. So let's zoom in on this. If we do that, and this is a cut we have made right here. And this is point A. So if we've done that, we're going to start in the middle, right there, at our applied shear, and we're going to get bigger and bigger and bigger as we go away. Similarly, here. That tells us that our shear at A is going to be just from, let me get a color that hasn't been used. No. It's just going to be this portion. Just this portion. Color it in a little harder. Okay, there we go. It's going to be that. And the area of that, because we're making the thin-walled assumption, is going to be 2 inches, because this is 4 inches. That's 4 inches. And so that's going to be 2 inches times the thickness, which is going to be 0.4 inches. So that's going to be 0.8 square inches. And Q, the equation that we want to use for Q, is A times Y. A we found, now we need Y. Y is the distance from the centroid of the total shape, which in this case is going to be right there at 4 inches, and up to the location, the centroid of the area that we're looking at. Well, that's pretty lucky for us, because that's just all of this has a centroid that's obviously at 4 inches. So this is going to equal 4 inches for our lever arm times 0.8 inches squared, and that's going to give us 3.2 inches cubed. Popping that into this equation, we get that the shear stress at point A is going to be 3.2 inches cubed times 125 kips divided by the second moment which was given, which is 85.3 inches to the fourth, and divided by the thickness, which is 0.4. And that's going to give us 4.7 KSI. A lot of you on this problem had a lot of trouble identifying Q. What is Q? How do you find Q? What portion should be Q? I was okay with people who took this full area to be Q and then said, like, well, okay, there's that counts as thickness and that counts as thickness. That's fine. But you couldn't take the area of the whole thing, because obviously then the lever arm from the centroid of the area you're considering to the centroid of the whole thing is, it's the same area, right? So don't do that. This is definitely something about this is going to be on the final. So maybe brush up on the thin-walled assumptions that we make when we're dealing with thin-walled members for the final. All right. Have a good dead week.